Greetings to everyone. I am Chidambaram AL and my student code is PCM24072. I am currently in the third semester of the master's program in construction engineering and management at CEPT University. Today I will be presenting the outcomes of my integrated construction practice studio as part of the semester curriculum. In this studio, I explore the challenges commonly encountered in the conventional construction methodologies, especially in the context of high-rise commercial building. The study focuses on identifying these limitations and developing the improved solution through integrated construction practices, supported by advanced technologies such as building information modeling and lean tools. These tools help address construction challenges more effectively, enhance the coordination, bridge the communication gaps, and bring all stakeholders onto a common collaborative platform. This approach minimizes the delays and supports successful project delivery within a defined budget and schedule. Here my portfolio demonstrates the detailed employee information requirement for the project, quantity takeoff for three disciplines, and 5D simulation. For this study, I examined the high-rise commercial building located in the SEZ zone, Special Economic Zone of Gift City, Gujarat. This project is located at the road number 12 of Gift City with a strong regional connectivity. The development is a greenfield commercial project comprising the rental shops and office spaces. The project is designed in such a way that the entire building is rented to only one client. The land area of the project is 2,262 square meters, while the built-up area totals 21,646.4 square meters. The project configuration includes three basements, a ground floor, and 15 floors. The estimated total project cost is 95 crores under an item rate contract. The project commenced on 26th May 2022 and is expected to be completed by 31st March 2026. The studio scope includes the 14th floor and a basement one for the modeling process. An employer information requirement (EIR) is a document that details the client information needs and management expectation for the BIM project. The process flowchart shows the different information required for the project delivery. OIR, Organization Information Requirement. PIR, Project Information Requirement. EIR, Employer Information Requirement. Once these requirements are collected from the client, then the preparation of pre-BIM execution plan will start, and finalization of BIM execution plan will be completed. The risk matrix and RACA will develop with information model delivery schedule to deliver the project on time with requirements specified by the client. EAR is divided into three main categories. Management requirement. For management requirement, we followed ISO 19650 for this project as per the client requirement. Technical requirement shows what all the softwares we used to deliver this project. The project key softwares includes AutoCAD 2026, Revit 2026, Navisworks 2026, and MS Project 2013. Commercial requirements includes data ownership, licensing, usability, client-specific project requirement, material and functional data, information exchange methods, and applicable standards. Target level of development for around 300 architecture, structure, and MAPF services for both basement 1 and 14th floor we are taken. And for already 400, architectural includes basement 1 and 14th floor. For structural, only 14th floor we are taken for the Revit modeling. To understand the major on-site challenges, we conducted a meeting with various stakeholders, including the contractor, PMC, client, and the consultants. The table highlights the specific challenges identified by us from the client, and we proposed the BIM use and lean tools to solve these issues. The first challenge raised by the client was the need to link the model with time to establish a clear flow cycle plan for the basement and 15 floors. We address with this by implementing 4D simulation along with a lean tool, last planner system to support a reliable scheduling. The next key issue was related to the cable tray routing in basement 1. Multiple cable tray of different widths passed to the twin key basement 1 in 2D drawings. We resolved this by using 3D modeling and visual management, assigning the different color codes for trays of different widths, which eliminates the confusion. We also developed the RCA matrix for the entire project lifecycle to clearly define the responsibility of all the stakeholders. Our team consists of 4 members and we divided roles among architectural, structural consultant, contractor, and a BIM coordinator. And each member took the responsibility for one MAPF service within the scope of work. For development of LOD 300 model, the BIM coordinator is identified as responsible and accountable, while the structural and architecture consultant are responsible and the contractor is to be consulted. Next, in top right corner shows that we established a unique naming convention for drawings in alignment with ISO 19650 guidelines. The first four letters represents the project name and the next four represents the organization name. A table also shows the file format used for different software along with a naming convention assigned to each discipline. After knowing the requirements and then the challenges from the client, we develop the Revit modeling. The Revit modeling begins with referring the AutoCAD drawing and setting up the floor levels based on the 2D design information. A comprehensive 3D model is then developed according to the 2D drawings, followed by the class detection and resolution. Structural modeling includes columns, reinforcement, slab, PT beams, and HVAC modeling includes pipelines, FCUs, and air ducts. Here I showed that structure LOD 300 model and structure LOD 400 model. The structure LOD 400 model with reinforcements. And inside the structural model, there is an HVAC model, which has been zoomed in the circle. And the modeling challenges encountered include the absence of shear wall markings in the 14 floor plan, modeling constraints related to trapezoidal PT beams, and coordination issues at the bottom beam interfaces. These challenges were addressed during the modeling and coordination cycles. Next come to a quantity takeoff. After development of LOD 300 and LOD 400 model, the class free model is used for quantity takeoff for architectural, structural, and HVAC elements. The slide shows that quantity takeoff for the architecture elements. The elements we developed includes wall, doors, staircase, wall plaster, curtain wall, and floor finish. The table shows that masonry wall quantities includes 150 mm, 200 mm, 300 mm, and 400 mm thickness, with total manual quantity at 132.069 meter cube and rivet quantity at 132.48 meter cube. The reason for the variance is a minor deviation due to missing MEVF cutout dimensions in some locations in 2D drawings, which are not incorporated in the manual calculations. For LOD 400 curtain wall, the comparison shows values for glass panels, rectangular mullions, and corner mullions with variance percentage below 1%. The overall comparison for 14 floor architectural elements has been carried out and the cost savings for each elements are identified and represented as a pie chart in the right corner. Using LOD 400 Revit model yields a cost saving of rupees 5,930 per floor, demonstrating the value of BIM during tendering and the material management stage. The structural LOD 300 takeoff includes column, beam, cross slab, shear wall, and reinforcement. Shear wall quantities for the 14th floor include a thickness of 300 mm, 400 mm, 550 mm, and 600 mm, with the minor deviations between the manual and Revit values. The variation is shown in the graph is attributed to the absence of door opening in the 2D drawing, while the actual site condition there is an opening. So we adjusted 3D model and the opening is not considered in the manual calculations. LOD 400 reinforcement comparison, which has been shown in the bottom of the table, which includes slab, column, beam, and shear walls for the 14th floor, with the minimal deviations, which can be seen in the graph. The overall comparison for the 14th floor structure elements has been carried out, and the cost savings for each element are identified and represented as a pie chart in the right corner. Using the LOD 400 model for structural elements provides a cost saving of rupees 14,810 rupees per floor, highlighting the benefits of accurate BIM-based quantity extraction. Next comes to HVAC LOD 300 quantity takeoff, which includes the pipeline, fan coil unit, elbow, air duct, and the pipe fittings. The pipeline quantities for the chilled water supply, chilled water return, and condenser lines are shown deviation due to unclear height information and invisible under pipelines in 2D drawings, which are included in the manual calculations but not in the modeling process. So the below table, there is a graph which shows that the air duct quantities includes the fresh air duct, supply duct, and extract that, which corresponding manual and rivet comparisons. There is a slight deviations because of that clash between the cable tray and then the ducts, which has been detected in the 3D modeling. The overall comparison for the 14th floor mechanical elements has been carried out, and the cost savings for each elements are identified and represented as a pie chart in the right corner. Using the LOD 400 model for HVAC quantities result in a cost saving of rupees 93,471 per floor, demonstrating the BIM impact on tendering efficiency and material management. Next come to a 5D simulation process. The 5D simulation process begins with developing a class-free LOD 400 structural model and extracting the LOD 400 quantities for the lookup scheduling. The 14 floor LOD 400 model has been taken as a scope for the 5D simulation, and a schedule was prepared for the 14th floor as per the item information. The below flow chart shows that the process flow for the 5D simulation. First, the LOD 400 model has been developed, and the MSP schedule for the 7 weeks has been incorporated in the Navis work, and then the EVM for the MSP has been done, then incorporating the Navis work, and then adding the manual columns in a timeliner and adding the manual cost. Then overall simulation has been taken by adjusting some settings in the Navis work. Actually, the schedule was planned to 14/10/2025, including the major activities like reinforcement, casting for all the elements like slab, beam, column, and shear wall. But due to the festival break, there is an RMC plan shutdown. Due to the casting was delayed 1 week, and after the break, the casting was done for the 14th floor as actual on 21/10/2025, which has been shown in the top table. We captured this delay and deployed the 5D model, shows a delay in the slab casting. So EVM analysis was created in the MSP, which shows in the right corner. The table shows that CPA is 1 and SPA is 0.87. There is no cost overrun, but schedule is begun because the planned activity is not completed actually on site. Next, come to the results of the 5D simulation. The top EVM graph shows a comparison of BCWP, ACWP, and BCWS. The orange color shows the BCWP. Here you can identify that the one activity has been delayed and the schedule is begun, 0.87. The next bottom graph shows the comparison of CV and SV. You can see that CV is on track, but SV is in slow, so 0.87, which shows a delay in the activities which are planned. The manpower cost graph shows that different category of manpower, how much cost has been happened for these 7 weeks. And the material cost graph shows that the material cost for these 7 weeks for different category of material like reinforcement, concrete. So the reinforcement has 44 lakhs 79,300 rupees for the 7 weeks planned activities. The next 5D simulation results video shows that week 7, 14/10/2025, the slab has not been casted. Because of the Diwali break, the RMC plant has been shut down. So after the Diwali break, they casted the slab. That has been week 8, 21/10/2025. So in this we can clearly identify that there is no cost overrun, but schedule is behind 0.87. So you can scan this QR code for the detailed 5D simulation video. So the end result shows that CV equal to 0. Actual cost has been planned as per the plan. CPA equal to 1. Cost performance is on track. SV equal to minus 10.91 lakh, which shows that the schedule is behind. And SPA equal to 0.87. Work progressing at 87% of planned rate. The comparison between the conventional and ICP-based approach is presented across project initiation, design development, pre-construction, construction planning, and construction execution. Traditional methods include conventional briefing, segregated consultant workflow, manual contract takeoff, limited visualization, conventional scheduling, and frequent coordination gaps. The ICP approach incorporates EAR, BIM execution plan, standardized CDE, class detection, automatic quantity takeoff, site utilization planning, 4D simulation, 5D EVM analysis, and last panel system for construction. Documentary outcomes includes resolved critical class, saving 10 lakh in rework and 1 lakh per flow savings to reduce wastage. So the conclusion for the EAR. EAR showed missing standards and inconsistent consultant formats. Data exchange rules show that CDE prevents outdated drawings. The quantity takeoff. Automated quantity takeoff exposed manual versus BIM quantity difference, enabled faster extraction, reduced wastage, and show the value of AOD 400 model in tender stage. The 5D simulation. The simulation linked cost with model quantities for budget clarity and visualization the sequence of activities with total cost. Thank you for the valuable time.